Okay, so we're going to consider a velocity field where the x and y components of the velocity are given by u is equal to cx divided by x squared plus y squared, and v is equal to cy divided by x squared plus y squared, where c is some constant. So our goal is to try to obtain the equations of the streamlines. So let's start out by writing the slope of a streamline, which in this case is just dy over dx. Now we can use our special relation where we have dy over dx is equal to the v component of our velocity divided by the u component of our velocity. So in this case, what we can write out is for v, so that was cy divided by x squared plus y squared. And then for u, that was cx divided by x squared plus y squared. So we can make some cancellations here right off the bat. So we can cancel out our x squared plus y squared, and we can cancel out our c's. So now we are just left with y over x. So that doesn't look too bad, right? So now what we can do, we can divide by y. So we have 1 over y dy, and then we can multiply by dx. So we have 1 over x dx. So now we can do an indefinite integral on both sides. And then what we will be left with is the natural log of y is equal to the natural log of x plus some constant c1. Now c1, that's essentially the combination of the constant we get from this integration on the right-hand side minus the constant that we get on the left-hand side, because either or, constant minus constant, still give you a constant. So we can just summarize that as c1. Now, from here what we can do is we can then say e to the natural log of y, that's going to give us y, and we can set that equal to e to the natural log of x plus c1, which, using our log relations, we know we can split that up and do natural log, or e to the natural log of x times e to the c1, which will give us x times c, where we can say c is e to the c1. So in the end, we can say that our streamline equation is going to be y is equal to x times some constant c. Now remember, we can get a different streamline by inputting a different value of c. So essentially for this, let me draw a little graph here of what we're looking at. So we can see that they'll essentially be originating from this origin point. And then we'll have our streamlines essentially emanating from this origin. So we can have maybe one at this angle, we can have one going at this angle, maybe one coming out here, one coming out here, whatever it may be. That's essentially kind of what it will look like. So we can write that out here. We can say our streamlines are emanating from the origin in straight lines.